Hi guys, this is Mrs. Reed, one of the 7th grade math teachers. Today we are going to expand what you guys learned yesterday with rational and irrational numbers. So let's just review the definitions real fast. Rational numbers are numbers that can be expressed as fractions. This includes natural numbers, integers, and certain types of decimals. So rational numbers are decimals that repeat or terminate, which means that it stops. So rational numbers are numbers that can be expressed as fractions. This includes natural numbers, integers, and certain types of decimals. So any kind of number that can be represented as a fraction, it is rational. If it's a decimal that can be represented as a fraction, it is a rational number. And the key thing here is just to remember that decimals that repeat, so like 0.2323233, or if the decimal stops, it is rational. Okay. Then we have something called irrational numbers, which are numbers which cannot be expressed in a ratio or as a fraction. So irrational numbers are decimals that never repeat and they do not stop. So if it's like 0.254791032 and it keeps going, that is going to be an irrational number. I always tell my students the easiest way to figure out if numbers are rational or irrational is first figure out if it's irrational. Is it a decimal that repeats and does not stop? If it is, it's irrational. If it's not, then it has to be a rational number. Okay. So let's look at some different numbers down here, and then we're going to decide whether they are rational or irrational. Let me get this situated here. Okay, there we go. All right, so 0.8. When you guys look at 0.8, it is a decimal, and does it stop? Well, yeah, there's no numbers after it, right? So if it's a decimal that stops, that means that it's a rational number. Look at the square root of 64. Remember, square roots are, if you're trying to find out the square root of 64, you're saying to yourself, what number times itself will give you 64? And hopefully you guys are saying 8, which is a whole number, which means that it's rational. Next one here is the number 0. Obviously, it's not a decimal that repeats and does not stop, so it's rational. Next, we have 0.123549 ... So it's a decimal that goes on forever. And does it have a pattern? Nope. And does not have a pattern, which means that it doesn't repeat, so that is an irrational number. It's a decimal that does not stop and it never repeats. Next one is negative 19. Hopefully this one's pretty easy. That's a rational number. Next one is negative square root of 100. Again, square root of 100 means what number times itself. Sorry, the bell's going off. What number times itself will give you 100? Hopefully you guys are saying 10 because 10 times 10 is 100. Put a negative before it, so it's negative 10. So would that be rational or irrational? Hopefully you guys are saying rational there. This next one, we have 2.342443442. So first off, it is a decimal. It goes on forever, so it does not stop. And then does it repeat? Do the numbers repeat themselves? They do not. So this is actually irrational. All right. Next one is 3/7. Oh, sorry, you guys couldn't see the other one. The next one is 3/7. So it is a fraction. Anytime you see a fraction, that is automatically a rational number because that is the definition of a rational number. It's any numbers that can be expressed as a fraction. So if it's a fraction, it is definitely a rational number. All right, next one, we have the square root of 75. So I first want you guys to think, is there a number times itself that would give us 75? Is there any number times itself that will give us 75? And if you guys remember from Friday, you guys used the activity sheet. It had the sieve of Eratosthenes on the front and then the square roots on the back. If you guys look at that, there is no square root of 75. There is not a number times itself that will give you 75. Now, here's the trick. If it is a non-perfect square root, just like this one right here, it is going to be irrational. Okay, this one was the square root of 64, which was 8. So that's a perfect square root, so it was rational. Square root of 75, there's no number times itself that will give you 75. So that's a non-perfect square root, which gives you irrational. Okay, let's do a couple more here. 6 2/7, rational or irrational? That is rational because it is a fraction. Next one, 12.67 repeating. Be careful on this one. 12.67 repeating. Is it a decimal? Yes, it is a decimal. Does it stop? It doesn't stop, but do you see this line right here? That's the repeating sign. So if it repeats, it is actually rational. The only way that makes this irrational is if that repeating sign went away and then it had a bunch of different numbers after it. All right, next one, square root of 121. So you can use your sheet that you guys did on Friday or just think, is there a number times itself that gives us 121? Hopefully you guys are saying yes because it's 11. So this is a perfect square root, which means that it is rational. All right, next one, 12/5. Again, definition of a rational number is any number that can be expressed as a fraction. 12/5 is a fraction, so it is rational. And my last one over here is this symbol. Can anybody recall what that symbol is? This is the pi symbol. So if you guys don't know what the pi symbol is, pi is a really, really long decimal that never stops and it does not repeat. It's like 3.14159265535, blah, 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 blah. And it goes on forever. So once again, it's a decimal that does not stop and it never repeats, which means that pi is an irrational number. And we're going to get more into pi in 7th grade in quarter 3 with geometry, because that's when we'll start finding area and circumference of circles, and that's when pi really comes into play.